the situation most of the time. Yeah. Thank you. Lecture. What number are we up to here anyways? 16? No. Let's try that again. All right. So, if I remember right, we left off kind of doing moments of inertia, right? Yeah. So, this calculator's out. I'm going to throw a bunch of problems up. I'm going to go over narratives. And then we're going to make things complicated with some weird shapes. Okay. So, why am I in red? What's the I for a circular shape? It's okay to use the internet, use your book, look it up, don't guess. Pi d to the fourth over what? Everybody agree? Anybody find anything different? Okay, for round object? Just because Mark got it doesn't mean it's right. Tyler disagrees, so now we got a debate. Which is it? Frank, you got the book open.
Here's pi d 54
over 64. Okay. So, where'd you find yours? Oh, you guessed. Oh, cool. You're close. Okay. But there is a value that's pi d to the fourth over 32. It's the polar section modulus when we do torsion. Cool. That would be J. All right. Area, as long as we're at this. Area of a circle, folks. Okay. What's the C going to be? We can probably spend most of the morning here making a cheat sheet for you. Wouldn't that be handy? What's C going to be? Centroid of a circle. 2 pi d over circumference. Yeah, sure. What's the centroid going to be? I'll even give you a hint. C is going to be d over 2. Cool. Let's, what the heck? I call you Mark. You're Nathan. Who the hell is Mark that sits back there? I don't know. Never mind. Sorry, Nathan. Reminds me, attendance, or else I'm going to get shot. They call for COVID. Last thing you want the dean going on. I don't know who is sitting where. Or maybe you do. Maybe you all want the week someplace else. Today is the 4th. All right, let's see. Henry's here, Frank's here, Montana's here. Cool. All right, so I got that done on here. What's the I for a square? Okay. The area, base times height. And the C, height over 2. Okay. Now, I'm going to do something just to make sure you guys are getting what the book's doing sometimes. So if you remember from math, that's your x-axis, that's your y-axis, right? And you were given a line that went here, okay? What's its value? Let's say it's at 2, okay? What's the equation of that? Y is equal to, y is equal to 0. We don't know anything in height. What's the x equal to?
2.
2, okay? But it's infinitesimal up and down. It's any y. Okay? So when they tell you something with moments of inertia and trying to pick things, that's usually labeled x. Okay, that's that line. That xx could go anywhere in this direction either way. Okay, and if they give you a yy, it's that. Okay, so ideally when they do this, this is I of yy, and it's any y up and down that rectangle. Make sense? And when they do x, it's any direction left or right on that rectangle. Okay? Cool. Now, I said rectangle 3 times, I got a square up there. Is there any difference between a rectangle and a square outside of the basic geometry? We're going to use the same equation, and everybody's happy. Okay? So cool. All right. Not that we have any of this, but it'd just be fun to, as long as we're looking things up. How about a triangle? Most of the time we would never make any shapes out of this stuff. not very many calls for triangular shaped beams or columns. But some architect could actually do something really crazy. So you're probably going to look that one up, because I don't even know what that one is up top of my head.
Won't have,
So I'll give you the area. Yep, 1/2 base times height.
I equals the total M times R times 2.
I is equal to summation of M times what?
Times R2.
Times 2?
Yeah.
That one just seems weird. Frank, is there one in the back of the book for a triangle? I may have just pulled up a shape that.
I think base times height cubed over 36. That's not what it is.
I like that better. Base times height cubed over 36.
I was doing like math.
Cool. All right, Centriod. This one's actually one you should know, but you may not remember. Where's the centroid on a triangle?
Towards the bottom.
Towards the bottom. Okay. Anybody remember what that one is? Okay. Or if you have to, you can always do 2/3 of H will get you down from the top. But considering this would be 0, moving up that way, this would be 1/3 H. Make sense? Okay. I'm going to take you into some places where knowing where those things exist for triangle are really important. Okay? If they're 1/3 from the base up, right? Starting at the baseline. Okay? Shouldn't be too much of a problem there. Frank, is there any other odd shapes in there? They don't do octagons or anything stupid, do they?
They have a semicircle.
Oh, that's always a good one. Yeah. Semicircle. Let's not do it so wide. And there we go. All right, so what do we got for a semicircle? We got I, we got area, and we got C. So we got a diameter here. We do have a radius. Okay. Our centroid is likely to be someplace in there. So what's I?
I times R cubed, I've got to the 4th over 8.
Pi times R cubed
To the 4th, sorry.
to the 4th over 8. Okay. Area?
Pi R squared over 2.
And if that was in pi d to whatever, pi d squared over 2 over 4, and what are we going to get? They want to do the math? Two drops to the bottom, 4, 8. You thought I was just here to teach you strengths. All that fun stuff in math that you learned once upon a time that they said, oh yeah, don't worry about it. Yeah, you do need to worry about it, right?
Wait, I'm gonna, for the I, is I R divided by 8?
Yep. So what is it if it's D? What's it if it's pi D with 4 divided by something? Well, it's still a 4. But is it really? So R becomes D over 2, right?
Yes.
So what's the denominator become?
Do not know the denominator.
Over 16.
Why do we put like is that just how
The 4.
yeah.
Because the area of a triangle of a full circle is pi d squared over 4. But now we only took half of it, so we take half the diameter. And then 2 here in this denominator of the numerator becomes the multiplication of the denominator. I'll make 8, which is why we get 16 there. Does that answer your question, Alosh? You can use any one you want, all right, as long as you're consistent and don't screw it up. Will you screw it up? Probably. That's the nature of learning this stuff. Try to pay attention and don't get caught, okay? There isn't any other strange ones in there, is it?
A quarter circle.
A quarter circle. Really? Oh, this book. All right. A quarter circle.
Never did C.
You didn't do C either.
Oh, we didn't do C. Okay, what is C? Let's get C off here where we can actually see it. What's it C, Frank?
Something in the book for it.
Nothing in the book for it. Where would C be?
It's like a little bit above midsection.
Yeah, so it's someplace up here.
Would it still be a diameter over divided by 2?
No. Cool, what is it?
Radius over 2?
Radius over 2? That'd put us someplace out in the center out here. Okay. Let's do the semicircle one, or the quarter circle. Centroid is going to be someplace in there. And we have pretty much an R. So what's that kind of look like? Oh, I should have brought up here. I have these great shapes where we can do centroids on things. I gotta go out the shed and dig it out. So first of all, let's start with this obvious question. Then we can solve the math for it, but I'm not even going to get hung up on it too much. A quarter circle kind of looks like what? Triangle, except it has a little bit more curvature to it. Instead of a straight line, we throw that extra bit of material. Okay, so we really have centroids based on where the mass finds its center. Okay, so this won't be 1/3 from the base. The height divided by 1/3. height times 1/3 or h divided by 3. It's going to be slightly something else, but it's going to be something like that, okay? And they don't give it to you in the book?
I think I got it. For what? For C? What do you do?
C for gravity. Yep, 4r over 3 pi. So this one's 4/3 r over pi, okay? And we'll come back to this one in a second, but let's do the centroid there as long as we're having fun. So if the centroid is that for a semicircle, what's the C for a quarter circle?
Same thing.
Now,
Look at it.
is it really?
4 over 3 pi.
4 over 3 pi.
No, 4r over 3 pi.
4r over 3 pi. That's funny. Yeah, something's funny there. Because what's missing in this thing? I got all that mass. If I have a full semicircle, I got mass on this side and I got mass on this side. Right? It's got to find its center based on that. It'll be in the center plane. Might be 4/3 up.
Get that.
Yeah. And then it's the radius, like I thought. A quarter circle could be that height, but it's going to shift to the right or left, depending which way it is. To give you the C for the quarter circle. Yeah, okay. They bounce on both ways. All right, I'm good. I'm good. All right, so C for this is 4/3 r over pi. And this is the reason. That shifts off center, where this one is on the center line. There. Okay? So it's both ways. All right, I for it is what, Frank?
Pi r to the 4th over 16.
Pi r to the 4th over 16. And if you want to do D, probably shouldn't at this point because we're getting crazy. Area?
Pi r squared over 4.
Okay. Here's your cheat sheet, folks. Yes? If it's not in the back of your book, this would be the point where I'd say, write it in the back of your book. But it is in the back of the book. If you're using it electronically, you're getting ready for an exam, and you want to put it on a piece of paper. Make sense? Okay. Cool. All right. So given all those different shapes and stuff, let's go play with some. All right, so XX, YY. All right, give me the I for this and the C. And let's make it 8 inches here, 2 inches there. Actually, do this. Let's do base, and let's make base equal to 2, 4, and 6, and we'll do all 3 of them. And we're going to look for it in the YY. And C in the YY. So going up and down. So C is going to be pretty constant. Let's do C first, right? C is going to be H divided by 2. Okay. H divided by 2. In this case, it's going to be 2 divided by 2 equals 1. And I'm sorry. What the hell was I thinking? It's having too much fun there. It's 8 inches. So it's got to be 4 inches. So they're the same all the way across. Okay? I for this, base times height cubed over 12. And the first one's going to be 2 times 2 squared over 12. Going to equal what? Thank you. Is that what you said?
No, you got 2 2s there.
I got 2.
For ID.
Oh. Thank you. I knew that was looking too easy. I haven't had enough caffeine today. Hey, literally in the last class, I gave them all a break so I could go to the library. And I got over there, it's like black iced tea. No lemon, no flavor, straight tea. All right, so what's the answer?
85.33.
85.33 inches to the 4th. Okay. How about B? Or B. B equals 4 now. What do you got, Carter? 170.67 inches to the 4th. And for B is equal to 6. $256. Okay. Cool. All right. Sweet. All right. So, what's that actually tell me? So, think about it from a perspective of what's it mean? Go ahead, Orange. What's it mean to you? Go ahead. Yes. So, the bigger the object, the more moment of inertia it has. Not just moment, right? The moment requires then other things to go with it. But does it matter on the length of the object? No. And it's shaking his head, but he's ever so hesitant to say no, it doesn't. doesn't, right? Because what is it? It's that same piece, and I told you about the figure skaters. You know, when they're trying to do a tight spin, they pull everything tightly in, and then if they want to slow down, they extend their arms. Okay? And that slows them down on their spin and gets them whatever next comes up. But it gives you really tight moment of inertia if it's really small. If it's really large, it slows down. Okay? It's going to be an advantage when we're trying to design things with I-beams, and we get the flanges up. Okay? I'm going to do an I-beam next, just because it's so much more fun. But I want you to remember, this is something you can look up in the back of the book. Okay? So we don't have to reinvent the world on standard shapes. Okay? But I want to introduce you to a few things about this and why all the areas and stuff were very important. Okay. All right. So let's get back here. This was example 1. All right. Example 2. Let's do this. All right. Now, actually, let's modify this a bit. Yeah, we'll do that shape. Let's do 10 inches here. Let's do 1 inch. Typical. So 1, 1, 2 is 8. Let's do 8 inches in here. And let's make this 6 inches. Nice to put your arrows in the same place. And let's make this 10 inches. All right, now I'm just being OCD. Hey, did anybody in your lifetime show you how to draw arrows? Yeah? No? All right, so when you draw an arrow, you want it to end like so. You do this curve, and that curve, and then fill them in, okay? And it makes them more unique than if it's that, all right? Just FYI, okay? Do I always do it? No. But it sure helps sometimes when you're really trying to get your point across. My arrows right there, they just really bother me.
What's that little segment in the corner? I can't remember the number. The TYP.
TYP, I'm going to come to that one. So, here's another, and this is the reason I'm asking about arrows, but if you see TYP, actually, on a drawing, they are always capital. That means typical. And if I give you a 1-inch dimension, I don't give you anything else for all those other dimensions. Typical is for anything that's not labeled.
What's the number next to typical? I can't read.
1 inch. Sorry, that would be nice to clean that up, wouldn't it? How's that? Thank you. Oh, and by the way, the other thing is, geez, I really am getting OCD today. Your one should look like a line up and a little flag down the side. Just doing a 1 could be an I, could be an L, could be just chicken scratching. Yes, I might as well. Boy, you're as bad as I am, Laura. All right, must be the lack of caffeine that's telling me not to calm down. Just fight with it. I was told one, just let it go. Relax. The caffeine gets me riled up. Okay, now here's the interesting thing. We have something that's not standard. You can't look it up in the book, and we need to kind of take it in parts and pieces. Okay, so I'm going to do this. I'm going to label this one 1, this one 2, and this one 3. Okay, or actually, you know what would be better is not letters or numbers, but letters. Let's label this A, B, and C. Okay, and I'm literally going to take it into shapes. All right. So if I do this, take it like so, and then I'll take it like so. Okay, and let's see what other color we haven't used. Red. Okay, so we got 3 different shapes in there. I did it in 3 different colors so you can see it. You don't have to. Just know that we're going to break it into 3 different shapes. Okay? Cool? All right.
So we have to find the C and I.
Yes. And there's a table that I'm going to show you here. It's going to make your life somewhat simpler or more complicated. All right, so we got A, we got B, and we got C, okay? And then we're going to find, nuts, it'd be nice if I had my notebook here with me today. I like the format I use, and I'm trying to remember what it is. Area, Y, yes. Y, and let's get you a little higher here. Y, the area, and then the AY area, squared, cubed, yeah. Can I look in your book real quick? I want this in something like this. one more box out here. So I sub I of the object. Okay? All right. So this is actually going to be your centroid. Okay? That's your area of the shape. It's the multiplication of your centroid times your area to give you this. And then we're going to plug in, calculate the I of the individual shape. Okay? Everybody with me here? Okay, so for part A, assuming that we start here at this line at the top height of the H, what is the centroid of that shape? What's that? H over 2 or 1 divided by 2. Okay. Now, is that really where it is? No. Okay. So what I just threw in there was we had to establish where our line is. Okay. Now, every time I do this, it's always confusing. Okay. You get that. But don't can't. Okay. Protector's Guide to the Universe. The front cover of the book, once you turn the front cover open, says, or the galaxy. Don't can't. Okay. That's literally what you're doing here. I can choose any place along here becomes 0. Okay? And I do need to know where 0 is. All right? But I can also choose what I presume to be the center of the object to be 0. Okay? So really the y bar is from this point up to here, not just this dimension in here. Okay? That would be the true centroid of that shape, but not the centroid of the whole object. Okay? Now, there are advantages and disadvantages. So if I choose the very bottom, then I know where everything's referenced from. Okay? If I choose where in the middle is, I'm guessing. I don't know anything about that. Okay? So choose the very bottom or the top, and you're going to make your life a little easier. Okay? So really, what is y bar from the 0 plane is going to be 1 inch, 8 inches, and half. So 9.5 inches. Okay. The area of that shape, though, is going to be 10 by 1. Okay. And my y times a is going to be okay. And my I for a rectangle, and if it helps you, you're more than welcome to write them out here. So we are 10 inches times 1 cubed divided by 12, or 10/12, right? All right. Coming down to B. What's B going to be? I'm hoping 5 inches. Yes? Okay. And then my A, or yeah, the area for that one will be 8 inches squared. And then A times y bar 42.
So 40.
40. Okay, I thought I heard you say 42. That's what I thought. 8 times 5?
Yeah, 40.
40. Okay, and that area, mind your H is the 8 now. Oh crap, we never did put the I value in for top one. So 1 inch times 8 cubed over 12. What was the I for A? 0.83. And this one is going to be 42.67 inches to the fourth. Okay. C should be 0.5 inches. Okay. Our area, 6 times 1, should be 6 inches squared. 6 times 0.5 should wind up with 3 inches cubed, right? All right, and this one is going to be base times height cubed over 12. 6 times 1 cubed over 12. 0.5. Cool. Now, you want to find the true centroid of this thing, right? Because we got to know where it's spinning from. And if I was to take this, where's all the time go? All right, we'll pause there and finish it on one. Fun. I looked at 11:30, so oh, I got plenty of time. Sorry.